a real quick section on covalent bonding. There's a lot more covalent bonding things than ionic. So the ionic, if you remember, had hundreds. Now we have millions. And covalents are really varied. There's solids, liquids, and gases. And what you'll notice here is they are very different. They have low melting points. They do not form crystals. What they form are molecules. And again, they have much weaker bonds because they don't have that real extreme difference of pluses and minuses. So they have much lower attractions, and their lower melting points and boiling points are because you're only breaking intermolecular forces, which we'll get to later. However, because they're easier to do that, they are typically more flammable than ionic compounds. And again, the difference between ionic and covalent is that when you're doing covalent, you are sharing electrons, and you're very nice, and everyone likes you. So this is just an example here. Hydrogen showing that we're sharing, chlorine showing that we're sharing. One thing you do have in covalent bonds that you don't have in ionic are multiple bonds. So when you have one bond formed, so you have a single bond here, what's happening is two electrons are being shared, and that makes one pair. So if we have a single bond, that's really what's occurring. But then down here we're showing you we have double bonds and triple bonds. So when you have a double bond, you now have 4 electrons and 2 pairs, and then that's why we have this double bond drawing here. And if we do our triple bonds are very hard to maintain because there's so many electrons in one spot. You have 6 electrons, 3 pairs, and they're actually typically somewhat unstable. But that's an example of a triple bond. And then just a little thing down here. This first one's going to be strength, and this one's going to be length. And I'm just going to give you single bonds are going to be the weakest. Triple bonds are going to be the strongest. And single bonds will be the longest. And triple bonds will be the shortest. Let me move that one up. So you do want to know that because you have, for covalent bonds, because you have 3 pairs of electrons, your triple is your strongest while it's also your shortest. So you definitely knew that. And then just to show you how this works with electron configurations, here we have chlorine, and this is the first chlorine's electron configuration, the second electron configuration, and this right here, hold on if it likes me, this is the whole 3p, but if you think about when we draw 3p, we draw 3 lines, we go like 1, 2, 3, this is just showing you how they match up. This P1's filled, this P1's filled, this P's filled, this P's filled, but these 2 P's are not. This is where the overlap occurs, and you can see there's one area of overlap, which means there's only one bond. If you look at oxygen, however, again, these are all the P's that are in doing stuff. And you can see these first P areas are already occupied, they're filled. But if you look here, the second one is open and the third one. There's 2 areas of overlap, and that's how we get our double bond. So just kind of an idea of where those multiple bonds come from.